Okay, I want to do this video this morning. I want to keep it really quick. This is just an introduction to exponential functions, and I just want to compare them a little bit to things that we've done before. Previously, previously we've had equations where we had, I'm going to give some meaning to this in a second, but we've had a variable base, like x, and then we've had that raised to a constant, we've had that raised to a constant power, and we've looked at some of the behaviors of those things, and we've given names to them, and we've talked about what their roots look like and what their solutions look like. And I could see how somebody might think this, because of this exponent up here, is an exponential equation. So why might a person think, well, this is an exponential equation? This is not an exponential equation. This has an exponent, but is not an exponential equation. And what we need to figure out now is why. How can we tell if something is an exponential equation or not? And the test is right here. We talk about here that the base is variable, so we could take, if this was f of x equals this, we could take f of, f of 3. And f of 3, if you look, f of 3 would be not x anymore, but 3 squared. Let's look at it this way. F of 3 is 3 squared. Let's do this again. 3 squared is 3 squared, right? Could do f of 9 is 9 squared. So what's changing? The base is changing. That's the variable part, is the base. However, I'm suggesting to you not exponential equations. Or not an exponential equation. So if that's not true, then what makes something an exponential equation? And there's what we're interested in figuring out now. That's where we're going. We're trying to go to that. So now, instead of having a variable base, we're going to have a constant base. Constant base here with a variable exponent. So here we are, and asking ourselves what makes it a certain type of equation. Well, where's the variable part? The variable part is the equation. So now, instead of having x squared, now we're going to have 2 to the x power. And see, here's our f of x now. F of x is this. Hopefully you can see the difference here. Here we have an equation that contains an exponent, but the variable is the base, and the constant is the power, but not when we go to exponential equations. Now we have an exponential equation. Where's the variable? So these are exponential equation. So is this an exponential equation? How do we answer that question? Well, we look for the variable. Where is the variable? And if the variable is in the base, it's not exponential. But if the variable is where the power is, well, then we have an exponential equation, and this variable power, the word is the same, exponent or power, but variable power. So I wanted to make sure I was being clear on that. Also, if you just take a quick look, let's look at this really quickly. Let's look at this really quickly. And let's look at this equation really quick. Let's just compare a couple of them. Let's look at an equation like x squared. Now, I think we know what this is going to look like. So here, this is an exponential, right? Excuse me, this is not an exponential. This is an equation. This is actually parabolic, right? This is a quadratic function, but it's not an exponential function. Look at what it would look like if I put it in as a if I put it in as an exponential function, now I have that constant base here, and I'm going to raise it, and the power that I'm going to raise it to, that's where I'm going to put the variable. And look at this. Before I press go, try to imagine what you think this is going to look like. So here's that equation right here. So do these two equations look alike? I think that they do not look alike at all. And one of them is an exponential equation, and it's this one. So I'm hoping that you'll read along in Swakowski-Cole and compare these things. But these are the kind of things we're going to talk about, and we're also going to talk briefly in the next video about solving exponential equations. So keep up the good work, and I hope this was beneficial. This is what we're going to be talking about on Monday.